Lesson 89, we are going to revisit the ellipse. We did our first lesson on it, and then we already did a little bit of what the book does in lesson 89 with, well, what happens if the center is no longer at the origin? We did that early so that we could just focus our attention today on, well, what about the coordinates of the foci? So as we get ready to think about what is going on with that, I want us to remember the locus definition that we already learned. We learned that an ellipse has 2 points that are always inside the ellipse, and they are always on the major or longer one of the 2 axes. And what's special about those is any point that we want to pick on the ellipse somewhere, if we imagine a string tied to both of those foci and going to that point, that piece of string always stays the same length. So if I had these 2 parts of my piece of string, D1 plus D2 would always be a constant length for that string. Now, I also know some other things going on here. We know that this was an important distance. This was the square root of whatever was under the x numerator, and I'm going to call that a on this one. And we knew that this distance from the center was the square root of whatever denominator was underneath the y numerator. We also know that our major axis would then be the distance from out here all the way to this other vertex along the longer axis. So it would be a plus a, or 2a. Now there's another thing that's going to be special in this. And if I think about, well, what is this distance between the 2 foci? And for right now, I'm going to call that x. And then by symmetry, these 2 little pieces would have to match. So it would also be true that my major axis could be both of those m's put together plus the x. Now, what I'm really going to start doing, and I'm going to switch over to another slide here in just a moment, I'm going to be really, really interested in this distance right here. So I'm going to call that distance f. So what I labeled on this picture with x is really f plus f, or 2f. F is going to be really important when we get to the next slide. It is going to be the distance from, and this part is really important, the center to each focus. It is not what I labeled M in the picture. It is not the distance from a vertex to the focus. And that's going to be really, really important for us to remember as we work on this. So, my distance for my piece of string has to stay constant no matter what. My major axis is always 2 times a, or 2m plus that x in there. If I did my piece of string, if I were interested in the point, I'll do this one on the next picture, it's getting kind of messy. So we know that that whole piece of string has to be 2m plus x, the way we were just talking about. If I pick a point over here, my string is going to go from here to here, so that's going to be one of the m's. And then the other part of the string is going to go back to here, which is going to be another m plus x. So my piece of string is always as long as the major axis. And remember I said on this side, the major axis is also 2 times the square root of that bigger denominator. So on this picture now, I don't need that red piece of string anymore, so let me erase it real quickly. So on this one, if this was a square root of my x denominator, my bigger denominator for this picture, then my piece of string would have to be 2a. So now if I pick one of the vertices on the minor axis, the piece of string still has to be 2a. So that means these two parts would have to be symmetric, and I can label both of these with an a right there. So a is the square root of the x denominator for this picture. B is the square root of the y denominator, and we know b is that distance from the center to the one of the vertices on the minor axis. And here's that little f that I told you about, the distance from the center to one of the foci. So now I have a right triangle in there, and a squared equals b squared plus f squared by the Pythagorean theorem. What that means for how we are going to find our foci, it's usually going to be more helpful to us if we then rewrite this as f squared equals a squared minus b squared. So this is going to be distance from center to focus squared is going to be, now remember, a squared was our bigger denominator before we took the square root. Minus, and b squared was the smaller denominator. So this is what we are going to use to get coordinates of foci. We're going to take, before we take square roots to figure out vertices, we're going to take the whole bigger denominator minus the smaller denominator, and then take the square root of that. I'm going to give this to you the way the book does, where again, they break it down and you're supposed to memorize all of this stuff about which one, whether it's vertical or horizontal, and remember them all straight. I get confused with that, but I can remember big denominator minus small denominator, and then take the square root to get my focus length. So that's what you have right here, big denominator minus small denominator. Take the square root, and then you have your distance from center to focus, not from vertex to focus. On this part, you can write it down, but don't bother to remember it. Don't bother to memorize it. I can't. I don't have it memorized. What I do is I say, oh, here is my center, and I need to go along the major axis, however far that f is, and so I just use the geometry. If I start here and I go this far to the right, now I'm at this number. If I started there and go to the left, now I'm at that other number. Or same thing if it were vertical. Notice we can still have the center anywhere we want. We have to pay attention, have those denominators changed to, are they just x squared and y squared, or have they changed in any way? I'm going to go on and do a couple of examples with this. Let me know at the end if you would like me to come back to this page, if you'd like to copy any more from this page. So I want to model instead how we're going to go through thinking through these things. And each problem is a little bit different. It's not you always do this and then this and then this. It depends. Do they give you vertices? Do they give you all 4 vertices? Do they give you 2 vertices in the foci? If they give you 2 vertices, are they on the major axis or the minor axis? The foci always have to be on the major one. Do they give you the equation and want you to figure everything out? So you just have to put together all of these pieces that you know in a different way each time. Luca, your camera is not on. Please take care of that for us. So for this one, we start off knowing 2 of the vertices are at positive 5, 0 and negative 5, 0. So first thing we want to do is just to graph those. So 1, 2, 3, 4, 5, 0. 1, 2, 3, 4, negative 5, 0. Right now, I don't know if those are major or minor axes. That could be the shorter one or the longer. Next, they tell me my foci are at plus and minus 4, 0. That tells me this one is the major axis because the foci are always on the major axis. I don't need to write that word major in there. I just wanted to point that out for you. So I know this has to be a horizontal ellipse. So now I'm going to write down what I know so far. Well, I can also from this figure out where the center is. The center has to be exactly halfway in between those 2 blue vertices, or halfway in between those 2 foci. So exactly halfway in between, oh, the center does have to be 0, 0. So that tells me my ellipse is x minus 0 squared over plus y minus 0 squared over equals 1. In addition, I know that in the x direction, I went 5 each way. So that lets me know that under the x, I need a 5 squared. Or it's really going to end up being x squared over 25 plus y squared over something that I don't know yet equals 1. So now I've got to figure out, well, what goes underneath that y squared. So I'm going to do that with this formula that we just had, that f squared is big denominator, and that's important because I know this has to be my major axis. The x denominator must be the bigger one. And then I can put in, and I don't really care which letter you use, a squared, b squared, or whatever. I know that the distance from the center to each focus has to be 4. So I can say 4 squared 16 is 25 minus my b squared. So b squared is 25 minus 16, giving me 9. So b is 3. So that means 1, 2, 3, 1, 2, negative 3 from the center. That means this is what my ellipse looks like. My y denominator, remember, is not 3. It is that 3 squared, or 9. So do I have everything it asked for? Standard form, graph the ellipse, put my box around my standard form. Does anybody have a question on that one? Okay, this next one's going to be very, very similar. So now the vertices are at 0, 7 and 0, negative 7. So 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, negative 7. That tells me the center is exactly halfway in between. So at 0, 0. That tells me my equation is x minus 0 squared over something plus y minus 0 squared over something equals 1. In addition, I know I went 7 in the y direction, so now I know my y denominator has to be 7 squared, or it's going to end up being 49 when I write the final version. This one also tells me that the foci are 0, 4 and 0, negative 4. So again, this one, the foci are on the same one where they gave me the vertices. If they had given me 4, 0 and negative 4, 0, so if they'd done this, that would have told me that, oh, I really have a horizontal ellipse, and I'm going to erase that very sloppy, messy one here in a moment. That would have told me, oh, it had to be even bigger this way. And so the x denominator would have been the bigger one. But for this one, I know that the y denominator must be the bigger one. So I'll get rid of all those things that were really not correct for this problem. So now I need to figure out, like I did before, how far do I need to go in the other direction. So I know f squared is big D minus small d, and big D is 49. Small d is what I'm trying to find, a squared minus b squared. And I know that the distance, let's see, from the center to the foci, I figure out it's easy since the center is 0, 0. A little bit harder on some other problems later on. That distance is 4, so this has to be 16. That means b squared is 49 minus 16, or 33. So that has to be my small denominator. But the distance that I actually go for the coordinates is the square root of that. And let's see, that's between 5 and 6, since 33 is between 25 and 36. So 1, 2, 3, 4, 5, somewhere kind of in between there. 1, 2, 3, 4, 5, and maybe around there. Be sure when you draw your ellipse, you do not draw it like the foci are your vertices, but the foci are inside of there. So I need to clean up my standard form so I didn't leave it with a 7 squared there, and write it as x squared over 33 plus y squared over 49 equals 1. Anybody with a question on that one? So I can see the chat a little bit better here. Next one. So, okay, this time they aren't telling me vertices or foci. So they tell me it's horizontal. And that much is 12. So that's going to have to be my bigger denominator. And then going this other way, they tell me it's going to have to be 6. Oh, that's helpful. The center's at the origin, so I know the center's here. So since it is horizontal, that one was the major axis, so I need to go 6 each way. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6 takes me to negative 6. Center's still the origin. Minor axis is 6 total, so 3 each way. So 3 and 3. Okay, I can graph the ellipse. And I can go ahead and write the standard form of the equation. Nothing new in that. X squared over, let's see, I went 6 each way in the x direction. So that means I need to have an x squared over 6 squared, so 36, plus y squared over. If I go 3 up and down, 3 squared is 9. And that has to equal 1, so there is my find the actual coordinates of the foci. Whether they end up being nice numbers or messy numbers, I need to find something comma something to have coordinates. So what I'm going to do is I'm going to write down f squared is big D minus small d. So 36 minus 9 gives me what, 27? And if that is f squared, f needs to be the square root of 27, which would be 3 root 3. Okay, my foci must be on the major axis. So I'm not doing something like that. That would be on the shorter one, and that is not okay. I know that my foci must go from the center somewhere to the right and to the left, this particular distance. So I'm not going to mess with that formula that you wrote down. I'm just going to think about the geometry. So if I start here at 0 and I go to the right, I am going to get to 3 root 3. And that is just a little bit more than 5. So I'm going to put my dot out here. And that one's getting kind of cramped, so I'm going to write my coordinates of the foci out here separately. 3 root 3. And then I started at 0, 0, and I only go to the right. I don't go up or down, so the second coordinate is still 0. If I go to the left, 3 root 3, I'm going to be about there, so I'm just going to put a dot in there. And if I go to the left, that takes me to minus 3 root 3. And again, for this one, I did not change how far up and down I was relative to the center. So negative 3 root 3, comma 0. And when it says find the coordinates, that means both of them, write them as an ordered pair with a comma and with parentheses. Questions from anybody on that one? All right, then I have one last example. So this one gets a little more fun in my opinion, because now the center is not at 0, 0. So let's think through what's going to happen there. First thing we do is figure out what the center is. So I want everybody in chat, write parentheses, comma, parentheses, what are the coordinates of your center, and go ahead and hit enter for me. And I'm seeing lots of correct answers, negative 2, positive 3, the opposites of both of those. So we are going to plot that, negative 2, positive 3, and there is our center. From there, I need to go, square root of 9 is 3, in the horizontal direction, the x direction, since the 9 was under the x. So not from 0, 0, but from this dot, I need to go 3 to the right and 3 to the left. And I'm going to label those because they will be vertices of my ellipse. If I started at negative 2 and went 3 to the right, now I'm at 1. If I start at negative 2 and go 3 to the left, now I am at negative 5. If I started at a height of 3 and just go left and right, I'm still at a height of positive 3 for the y coordinates for both of those. For the other two vertices, now I need to take the square root of 16, so I need to go 4 in the y or vertical direction from that center. So again, starting at negative 2, 3, I'm going to go up 4, 1, 2, 3, 4. So I was at 3, now I'm as high as 7. And if I start at negative 2, 3, and go down 4, started as high as negative 3, now I'm as high or as low as negative 1. I started at negative 2 for how far left and right I went, but I did not change that. I'm still at negative 2 for the x coordinates for those. And then I can simply draw in my ellipse going through all 4 of those. That's nothing new. We had been doing some of those already. Now to find the foci. F squared is going to be big D minus small d. So in this case, 16 minus 9 is 7. So F is going to be the square root of 7. I want you to type in chat from the center. Am I going to go up and down or left and right? From the center to the foci. So type for me, am I going up and down or left and right? And hit enter. So I am going up and down, and that's going to be between 2 and 3, up and down. So maybe around there, and maybe around there. My circle is now so cramped, I'm going to write these separately. I put my 4 vertices on my graph. I also wrote down in my work what my center is. We always want to have those 5 points. And now we also want the coordinates of the foci. Okay, since I'm only going up and down, I'm not changing how far left and right I go. So both of the foci will start with -2. For the y-coordinate, I am now starting at 3 and going up and down root 7. So for the top one, if I go up, I'm at 3 plus root 7. At the bottom one, if I start at 3 and go down, I'm at 3 minus root 7. And when it says find the coordinates of the foci, that's what you need to write down. So questions from anybody on today's lesson?